Hi, this is Jim Plank. This is video number 2 for learning our open source framework for neuromorphic computing. I'm assuming you're in this repo and that you have already gone through the getting started material. What this video is going to do is go through the network tool. Well, you saw the link that I just clicked. That gives you information and a README that has the walkthrough. This is all the stuff that I'm going to be going through in this video today. So, again, I'm assuming that you have done everything that we did in the getting started video. So I'm going to go ahead and go to the directory I created when I made that video, which is right here. Okay, the network tool I've compiled. If you haven't, you should compile, nothing to go. And the network tool is a command line tool that's there in the bin directory. As with the processor tool that we talked about previously, if you give it a command line argument, that'll be a prompt. If you give it a question mark, it'll give you all the commands that it supports. Obviously, I'm not going to go through all of those right now, but I'm going to go through 3 little exercises. The first is going to be using the network tool just to look at a network. The second is going to be using the network tool to modify a network. And then the third is going to be using the network tool and the processor tool to create a network from scratch. Okay. As before, we're going to just use some simple networks as examples. You can see where to get this paper from the Getting Started video. What we're going to do is I'm going to grab this AND network. This is a binary AND network, super simple. Your neurons have to leak. So if these synapse weights are 1/2 and the neuron threshold is 1, so if both A and B fire, then this output neuron will fire. If only one of them fires, then only 1/2 unit of charge goes into this neuron. It doesn't fire, and then we have leak set so that it leaks away its charge so that you can do another XOR or AND command and it will work. Now, with the testing script, we can create this network. So if we recall from the previous video, we have a testing script. And if I give it a number, I believe this is just number 1, and I'll say yes. Okay, the AND network from figure 3, that's figure 3, perfect. Okay, now as we remember before, this created a bunch of temporary files, and in particular, this is the network. And in the previous video, we just looked at it in a text editor. Here what we'll do is we'll run the network tool to take a look at it. So we'll run the network tool, give it a prompt, and now the main command to load a network is called FJ. It's called from JSON. That's what it stands for, because you can actually just give it JSON instead of a file. But here, if you give it a file name, it'll read in that file. Okay, now there are a few nice things. As I said, the files are simple enough you could just read them with a text editor. But if you ask for information, it'll tell you basic information. This is very useful when you have really large networks so that you can see what's going on. So 3 neurons, 2 synapses, 2 inputs, 1 output, nice and easy. If you want to look at the neurons, there they are. If you want to look at the synapses, there they are. You will note the internal format of our software doesn't keep things sorted, which can be inconvenient. It's because they're held in hash tables. But if you say sort, it'll sort them in that way. Now, if you look at the nodes, they're sorted. If you look at the edges, these were sorted anyway, but it'll sort the edges as well, which can be useful. Okay, if you want to see the properties, again, we looked at them in a text editor before, but if I type properties or just say P, it'll tell me what the properties are of my neuroprocessor. I'm sorry, what my neurons and my synapses hold. Okay, that's what's going on. You can see here the edges. So again, we did this before. This is the weight of the edge, and that's the delay. And how do we know? Well, we look at the properties. The weight is index 0. So that's the first thing corresponds to the weight, and the delay is index 1. And so that corresponds to the other one. These types here are the data types. It's a horribly unfortunate decision that someone decided to make these integers rather than strings. But this means that the delay is an integer and the weight is a floating point value. And you can see that if you look at the network parameters. So when you want to write this out, if you say TJ for to.json, that will go ahead and spit out the JSON of a network. If we want to put it into a file, put it back into temp network.txt, that puts it back into a file. And as we went over in the previous video, we have the processor parameters here of RISP. You'll see this is saying discrete's false, so that's why the weights are floating point values. It also has leak mode being on, meaning we leak our charge away. Right, and so we could run this neural network and confirm that it does the AND operation. It's kind of what we did last time with XOR. I'm not going to go through that right now because I don't think it's hugely useful. Okay, now let's do activity number 2, which is let's change this network. So here's my AND network. Let's go ahead and modify this network so it becomes this OR network. Now the OR network's very similar, right? That has same neurons, kind of the same synapses, only now the synapse weights are 1 rather than a half, and that way, if either of A or B fires, then the output neuron fires. So let's go ahead and load this file back up. So, all right, and we can look at the nodes and the edges. Okay. And what do we want to do? We want to do a couple things. First off, we want to change the weights of these edges to 1. Now to do that, there is a command called SEP for set edge property. Okay? And I can say from edge 0 to edge 2, and if I want to set the weight to be 1, now that's working. And I can do the same thing for the other. Well, here, if we can just take a look, you'll see it's gone ahead and changed that. There's a command called SEP all, which if I say weight to 1, that's going to change the weights of all edges to 1. Okay. Obviously, I can do the same thing with the neuron threshold if I want. Here, if I want to change the name of this output neuron because it's no longer an AND network but an OR network, I can say set name. I think there's no underscore. Yep. Set name node 2, and I'm going to set the name to A or B. If I look at the nodes, okay, there they are. So simple ways of, those are very simple ways of just modifying the networks that you have. You can go ahead and write it. Here, I'll write it to temp_or.txt. And now we can use the processor tool to make sure it works. All right, so here, I'll go ahead and do the prompt. We'll do temp_or.txt. And here, ASR 0101, no, ASR node 0, 0101, ASR, that's apply spike raster, 0011. Okay, here, we'll run it for 10. And now when I do GSR, we should see at time 1, because unlike the XOR took 2 time steps, this only takes 1 time step to compute its result. So at time step 1, we should see nothing because neither A nor B fired. Then at time step 2, 3, and 4, we should see that that output neuron has spiked. So, yep, there it is. All right, we got all the spiking behavior is as we thought it should be. Okay, now the last thing I'm going to go through here with the network tool is creating a network from scratch. Now, creating a network from scratch is a more complex task, and the reason is that you should have a neuroprocessor in mind when you create a network. For example, with this AND network, I needed to set up RISP so that it would leak its charge away. I also wanted to set up RISP so that it had floating point values because the weights of these synapses was -1. I'm sorry, was 0.5. Now, so when you're creating a network from scratch, it's a multi-stage process. The first thing you do is figure out what neuroprocessor parameters you want to use. and then you're going to create an empty network for that neuroprocessor. That network will have no nodes or edges, but it'll have the proper processor parameters embedded in it, and then you can start adding nodes and adding edges. Now what we'll do is, let's go ahead and create this network. We went through this network in the last video, but it's got a bunch of things. It's got 5 neurons and it's got 8 synapses, etc., and some negative values, etc. Okay, so we're going to go ahead and set that up. Let me resize this so you can see it. All right. Now, RISP, I'll go over this in more detail in the next video, but RISP has some default parameter settings that you can use. And if you look in the params directory, you'll see a bunch of them here. Okay, now, the F ones stand for floating point, and the other ones are discrete, meaning their values have to be integers. And the numbers kind of denote what their maximum and maybe minimum values are. In particular, this RISP1 parameter setting, let's just take a look at it. It's one that's going to work nicely with this neural network. So you'll note the synapses, weights, and neuron thresholds are discrete, so they're going to be integers. The minimum maximum weights on your synapses are 1 and -1. So in fact, they can only take on values of 1 and -1 because they're integers. There's no leak in this network, which is what we want. Okay, our neuron thresholds, the max is 1. The minimum potential is -1, which is also what we want because that might happen. Again, we went through this in the last video where this neuron got a potential of -1. Okay, the max delay is 15. Doesn't matter. Our max delay here is 1. We could set that as we want. Okay, so this is the parameter setting we're going to use to create this network. So what we're going to do is run the processor tool. Okay, and previously with the processor tool, we used that ML command that says make a processor and load a network onto it, and you grab the parameters from the network. Here, we're just going to make a processor and not load a network onto it. And to do that, you use the M command, or make if you want. Okay, you need the processor name, which is RISP, and then you need the parameter file that you're going to use. So here is params risp1.txt. Okay, so now I have a processor loaded up on this, and now there's a command of the processor tool called emptynet. What emptynet does is it just creates a network file that has no neurons and no synapses, but it has the right parameter settings, right? And uses those parameters to set up what your nodes and edges are going to hold, and then creates an emptynet from it. So if I say emptynet and give it a file name, say temp.txt, okay, now it's put it into that file. So now if we look at temp.txt, it's going to be that exact thing, only it's crunched up JSONs because it's a little more efficient to have it that way. If you, well, we're going to run the network tool. So network, let's go ahead and use a prompt. We say read it in from there. Now, if we look at it, you'll notice it prints it out nicely. That's one of the nice things about the network tool is if you give it squished up JSON like that, it'll print it out with nice formatted JSON so you can actually read everything. Okay, so now what we're going to do is we're going to use the commands in the network tool that allow us to add neurons and synapses to our network. So I can say AN, that stands for add node, and I have to give it IDs, integer IDs. So I'm going to create 5 of them. I'll just give them 0, 1, 2, 3, 4. Okay. So now if I take a look, it's created those. You'll note it's already given them thresholds. And what it does is it gives it the max value here in this property. So in fact, when I create synapses, they're all going to have delays of 15 because that's that maximum value. Okay, but before that, let's go ahead and set the names of these. So we have set name 0A, set name 1B, set name 2. I'm just going to call it H1 because I don't feel like typing in that stuff. Set name 3, H2, and then set name 4, we'll call it A and. Oh, it's going to be XOR. A XOR B. right? Whoop. Uh-oh. Wants to read JSON. Okay, so if we take a look at it now, good, our nodes have names. And you'll note, again, it's unfortunate they're unsorted. It's because the internal data structure is a hash structure. If I say sort, it'll sort them, and now you can see them in the order in which you like. Often that's very useful, especially if you want to just use a text editor to mess with these things. All right, our neurons are in fact all that we want. So now let's go ahead and create our synapses. So to do that, we do AE for add edge, and you can do multiple of these. So we want to go from 0 to 2. Unfortunately, this doesn't take names, or I don't think it takes names. And we're going to have 0 go to 3. We'll have 1 go to 2. We'll have 1 go to 3. Okay, let's just stop there. Make sure we look right. See, they have delays of 15 because that's the maximum value here. We'll change that. Okay, now we need edges that go between 2 and 3. So A is 2 and 3, and 3 and 2. And then we also need the edges that go from 2 and 3 to the output neuron. So 2, 4, 3, 4. Take a look. There they are. Okay, let's set all those delays to 1. So we can do that by saying set edge property all of delay. And does it have to be caps? Yeah, it's got to match what's up here, right? That's how it knows. It looks at that property to see what that value is called. All right, so we're going to set all the delays to 1. Nice. And now we're going to want to set fortunately, all of the weights are also set to their maximum values, which were 1. So now we want to change the weights of these edges to -1. So here we'll say SEP 0 to 3 and 1 to 2. And we're going to set the weight equal to -1. Okay, looks good. All right, let's go ahead and save it. 2J, we'll just call it temp.txt. Done. There it is. It's formatted, which is nice. We already sorted everything. Looks good. Let's just run it and make sure that it works. So processor tool RISP ml temp.txt. See, that's how it knows how to make the correct version of the neuroprocessor, right? Because it's sitting there in the network, all of these parameters that we want. Here, let's do ASR. We'll do the same thing as we did before. Neuron 0 is going to get 0101. Uh-oh. Oh, I forgot. Oh, nice to have a mistake. I forgot to specify inputs and outputs. Let's go back to the network tool. So temp.txt. Tune is, you'll note there are fields here for what are my input nodes and what are my output nodes, and I forgot to set them. So I can say AI01 and A04, and now you'll see that node 0 and 1 are my inputs, node 4 is my output. That's what I wanted. Okay. You'll note they're not sorted because it's an internal hash table, which is irritating. But again, if we just say sort, in 2J now it's nice because the edges are sorted and the nodes are sorted. So we'll store this back into temp.txt. Okay, let's go ahead and run the processor tool. Okay, good. Now it loads. So now I guess it loaded before. I just couldn't give it inputs. So let's give it inputs. ASR 00101. ASR 10011. Run 5. GSR. Good. We've got it. Well, I say good. Like I've actually looked at the output. Okay. Output, we should have 2 time steps after the input. We should have the XOR. So at time step 2 here, we should have 0, then 1, then 1, and the last one should be 0. Even when I run it for another 10, should show nothing. Good. I'm happy. Okay. Hopefully you've seen that from this, it is very simple to write programs, be they shell script, Python, C++, whatever, that emit network tool and, if you want, processor tool commands to create networks. So for example, if you ever want to explore the DB-scan neural networks, which are sitting someplace in the, there we go, in DB-scan, which they have their own material, but the the programs that create networks that do DB scan produce input for the network tool, right? It's a nice and convenient way to create neural networks is to do that. Additionally, all these testing scripts, so like for example, when I said, when I did the testing script here, let's just say 1 and let's keep the files around, okay? You'll note that the commands to, well, what the testing script does is it actually goes in here. Let's just take a look. If you see in the testing directory, according to that testing example, there are a bunch of files, okay? And important ones are that we have a shell script for creating the processor parameters. So what I did here was to create my processor parameters, I took this RISP F+ network and then I changed the leak mode from none to all. So that created a processor. And then I have the network tool commands in this file, which go ahead and they grab that network and then they create, or they grab that empty processor, empty network file, and then they go ahead and create the network with network tool commands, okay? And then once that creates the network, then I have the processor tool commands that I run on it, and then they have to, when I run it, it has to equal that output file. So the nice thing is there's so many scripts there in the testing, right? And there's these last ones have some DB scan examples in there. So you have a bunch of examples of how to use the network tool, and even the processor tool, but using the network tool to create large networks. Okay, that's it for the network tool video. You should move on next to the RISP video, and then you'll be done. See you there.